Now, we're really not sure if those values are indeed points of inflection because remember, with points of inflection, concavity must change across those points. So what we need to still do is test the second derivative in the three regions that are produced between those points that we previously calculated. So I write down a number line, or place down a number line. I put on the two x values that I worked out on the previous screen, 1.18 and 2.82, and now I'm going to test the three regions created by those two values of x on our number line. So I've chosen the x values 0, 2, and 3, but you can choose whatever values you want as long as there's a value representing each of those three intervals. So when x is equal to 0, my corresponding value for y double prime is 40. So I put a positive on that interval on the number line. When x is equal to 2, my corresponding value for y double prime is negative 8, and a negative value is placed on that interval on the number line. And when x is equal to 3, my corresponding value for y double prime is 4, and I put a positive value down on that region of the number line. Remembering that the second derivative helps us to understand where a function is concave upwards or concave downwards, we can now conclude that the function is concave upwards in the regions from negative infinity to 1.18 in union with the region from 2.82 to infinity. Remember, functions are concave upwards when the second derivative is positive. Concave downwards, the second derivative must be negative. Therefore, for this particular function, it is concave downwards for x values between 1.18 and 2.82. On the last screen, we've taken all the information from the previous four screens and we've put it together to draw the curve, in this case, of our quartic function. I should mention that normally I wouldn't do this as the very last step. I would actually have my coordinate system drawn on a separate piece of paper, and as I work out each particular important piece of information, I would plot that information as I go. A lot of times it's easy to catch your mistakes if you do it in that fashion, opposed to collecting all the information and then plotting at the end. The only reason I've done it this way is that I just couldn't fit everything on one screen. Well, I've drawn my Cartesian coordinate system, placed a scale on both my horizontal and vertical axes. First thing I've plotted is the y-intercept for my function, which I know to be 0, 0. The next thing I've plotted are the maxima and minima that I had previously calculated using the first derivative. I knew that one of my maxima was at 2, 0, so that one's plotted. Another maxima minima is going to be at 3.41 and negative 4. And then the last one, the last extrema, is at 0.59 and negative 4. I've put little square green squares around those to signify that those are the extrema that I previously calculated. Now, we did talk about the increasing and decreasing intervals, but I'm going to look at that just in a few minutes. Right now, I'd like to plot my points of inflection. So my points of inflection were found by using my second derivative and setting it equal to 0, and we found them to be at 1.18 and negative 2.24. Those were the x and y coordinates, so that's been plotted. The other point of inflection is at 2.82 and negative 2.24, so that's been plotted, and I've used little green circles around those points so that you're clear that those are indeed points of inflection. The next thing I've done is try to take into account the concavity. We know that the function is concave downwards from 1.18 to 2.82, so I've drawn that in. I know that the function is concave upwards in two different intervals. The first one is from 2.82 to infinity, so I've drawn that one in, and then also from negative infinity to 1.18, and I've drawn that in. I should apologize. It looks to be concave downwards the way I've drawn it, but it's meant to be concave upwards in that portion of the curve. Now, if you remember, we kind of bypassed the information about increasing and decreasing. What I'm going to do now is take a look at this completed sketch of my curve and see if it adheres to the rules regarding increasing and decreasing that I had previously worked out. My function is supposed to go essentially from decreasing to increasing to decreasing back to increasing if you look at the work we had done previously. And that is the case when I look at my sketch. So this is complete, and this is the level of work that's expected when you do a curve sketching problem. It should be noted that when you're asked to do a question like this on a test or an exam or even on a quiz, you will only be expected to complete one of these questions in the allotted time. To ask 2 or 3 questions is totally unfair because there's just takes so much time just to complete one particular question.